Okay, section 10.1, and we are talking about circles. So we'll talk. Oops, daisy. I gotta turn that thing to that, and turn that to that. Now we're ready. All right. So it's circles and circumference. We've actually already talked about circumference this year, haven't we? I think, didn't we? Can't remember. At some point somewhere, I think I've talked about circumference this year, and I think it was in here. Let's just talk about what a circle basically is. And I know you know what a circle is, but let's be a little bit more specific. I am good at that, isn't it? That's perfect circle. I used to be terrible at drawing these things. Yeah. Yeah. Oh, maybe I'm not so crazy then, because I can't draw a perfect circle myself. All right, let's see what it says. Now, the definition says it's the set of all points in a plane equidistant from a given point. What in the world does that mean? Here's a given point right here. I don't know why it's hollow, but anyway, you got a point right here. And if I did this, watch, if I took a given distance, let's say from here to here. Everybody see that? Okay. And I'm going to do something right there. Now watch this. If the distance from this point to the end of this line segment right there is the same no matter where I draw it, so look, from there to there, it's the same distance, isn't it? Do you agree? And from there to there, all the way around, okay? It doesn't matter. It's the same exact distance. That little line segment right there did not change at all, did it? It just, look what I did. I'm just kind of rotating it around that point right there, and it's the same distance all the way around, and you would draw this thing called a circle. So it's the given, what is it again? It's the set of all points, okay, in a plane, so it has to be in just one plane, that's equidistant, that's the same distance from a given point. And what do we call that given point right there? We call that the center. Some people might call it the middle, but not in geometry. We call it the center of the circle. So that point is the center of the circle. That means that certain distance right there, okay, it's equidistant from all these other points. You see that? It's a set of points that's equidistant from that one single center point right there. So if I have a point right there, that distance is the same. If I rotated it around like I did earlier, that distance would be the same. Any point along this circle would be the same exact distance. What do we call that little line segment right there then? We call it the radius, right? So that length, or that equal distance, is the radius of the circle. Okay? And, yeah. We'll talk about a couple other things. Let's just talk about how to draw this. You know how we did, line segment? We would go line segment AB, or if I said line AB, I'd make my symbol look like that. Okay, and on, right? We've had different ways to draw things. Different. What's the word? Like angle. We did this. What is that thing called? Symbols. Thank you. I couldn't think of the word. My mind just goes sometimes. Right. We have different symbols to represent all these different things. Would you agree? Well, we have a symbol for circle as well. What do you think it looks like? No, it actually looks like a square. No, I'm only kidding. Yes, it looks like a circle, okay? Looks like a circle, and they put a little dot. Why would they put a little dot? Because it looks like an eyeball. Is that what they want you to look like? No. What is it? It represents the what? The center, yeah. So they put a circle with a little dot in the middle of it, and that represents the center, and that's how you would name the circle. Now, this is a point, the center right here. If I called it A, that point right there, we would just call this circle, what do you think? A, right. So whatever the center is, that's what you're going to call the circle. You're not going to use any more points. You're only going to use one point, and it's always the center point. Don't use any points on the circle itself. Just use the center point, and that's how we name the circle. Pretty easy, isn't it? So you put a little circle. Whatever the center is, whatever that point is, that's how we name that circle. Got that? Yeah, easy. Let's get rid of some of these words right here. I'm going to draw some other stuff in here. Use a different color? Okay. Orange. You said it first. Okay. Yeah, black wouldn't work so well, would it? Because you wouldn't be able to see it too well. What if we did this? Now, remember, this is the radius, isn't it? And the radius goes from a point on the circle. See this curvy thing around here, the actual circle itself? We call that on the circle. Let's do this while I'm thinking about it. This would be on the circle. What about a point here? That'd be inside the circle, and what a point here? Be outside. Or we call this the exterior, the what? The interior, and on. Now we just say it's on. The interior, right? We would just say that it's on the circle, okay? So we have interior points, exterior points, inside, outside, on. Everybody got it? Because a lot of people think of this as like a disc, right? Like a frisbee, where if you could put something actually on the frisbee, like right here, couldn't you? But that's not really on the circle. It's in the circle. So this little line, this curved line all the way around, is actually the circle itself. This is everything that's inside the circle. This is everything that's outside the circle. Got it? Because some people do get a little confused on that. So now let's do this. Let me draw another line segment. Let's just go from here to here. Now, is that a radius? It's inside the circle, isn't it? But it's not a radius. First of all, because it doesn't hit the what? Hit the center, okay? But it does hit 2 points on the circle, doesn't it? You see that? The end point of this segment is on the circle, and the other end point is on the circle. Savannah already said it. Did you look it up, or did you already know? Yeah. So this is the chord. This is the chord. All right? So we call it a chord. So it's a line segment that connects 2 points on the circle. It's a line segment that connects 2 points on the circle. Let's just name that. That'd be the radius. My S's are not completing, are they? Like the other. I did that before. It looked weird. Anyway. All right, that's a chord. That's a radius. What if we did this? Let's go, what color? Purple. Like this purple? Okay. I'll use pink next time. So what if we did this? Yeah, it's still a chord, isn't it? Because what is a chord? It's a segment that connects 2 points on the circle, right? Okay, but this one is a little bit of a special chord compared to this orange one right here. What does this do that this one doesn't do? It goes through the center. That's right. It goes through the center of the circle. Okay, so we call that the diameter. These are all words. I don't know, maybe chord you haven't heard, but I'm sorry. It's an A. I can't be perfect. I'm sorry. I'm not the neatest writer in the world. But it's diameter. Okay. All right. That's fine. Okay, so it's diameter is what we call it. Not sure where it comes from, but so that is the diameter. That's the radius. Now, what do you think is true about the length of the diameter compared to the length of the radius? It's twice as big. So one diameter is what? 2 what? Radii, right? Did you know that? Have I used that word? Seems like we've talked about the radius before, haven't we? I thought so. The singular. Have we not or not? Have we talked about radius? It seems like we have. Singular at the very beginning. Okay, and then the plural. I know. Just let me finish doing this. The plural is radii. That's how you spell it. Isn't that cool looking? You don't see too many words with 2 I's next to each other, do you? All right. Yes, Miriam. No. Good question. She said, is the radius considered a chord? What does a chord have to do? Both endpoints of the line segment have to lie on the circle. So look at the ends. Look at the line or the endpoints to this line segment. One lies on the circle, but one lies where? At the center of the circle. So that is not a chord. So radius is not a chord. Everybody see that? The radius, and it will never be a chord because it always hits the center of the circle, and it just goes to 1 point on the circle. Whereas a diameter goes to 2 points on the circle. Thus, it's a chord, but it does go through the center. That's correct. If this fell a little short, if that fell a little short right there, that's not a chord. And it's nothing. It's just a random line. It's just a random line that happens to go through the center. But that whole thing right there is nothing. Now, if I did this, then that would be a radius. Okay? Because the end point of that line segment is at the center. Okay? Now, of course, this radius is the same as this radius, isn't it? They're all equal. Okay? You can't have 2 different radii. Listening? You can't have 2 different radii in the same circle. They all have the same radius. So the radius in this circle is the same no matter where you place it. Does it make sense? Okay. Well, it all depends, and we're gonna do a lot more stuff later where you will be able to find the lengths of the chords and different things, but we're not going to do that today. That'll be tomorrow. We're going to talk a little bit more about that. Okay. Alrighty. That example's too easy. Let's just do this. Let me grab this circle again. So let's make it a little thicker. On the what? What are you talking about? Right there? Yeah, I don't know. Just because I didn't fill it, I guess. Maybe because, see, I grouped this. Watch, I grouped it, I think. Yep. And see, now if you click on it, now it doesn't have it. Okay. But now it does. Alright. I'm going to keep the center in there, though. Now watch, I copied and pasted. So tell me something about these. Yeah, I'll tell you what. I got to group it together again. Alright, copy, paste. There we go. Now look, I just copied and pasted it, so they're exactly the same, aren't they? So what we would say is true about the, more of a geometry word, if I copied and pasted, what would be true? They're congruent, right? These circles are congruent. Now what would you know about congruent circles? They have the same radius, right? So I could draw a radius here, a radius down here like this. If these circles are congruent to each other, we'll call this center A and call this center B. So I could say that circle A is congruent, right, to circle B. All right, so if I know that's true, if I know that those two triangles are congruent, what could I say about, we'll call this, what could I say about AX and BY then? They are equal or congruent to each other, exactly right. Girls, come on, a little chatty today. I don't mind a little bit, but when I'm talking, thanks. All right, so if these two circles are congruent to each other, these two radii must be equal to each other in length. So if I said the triangles were congruent and that AX was 5, very easily you should be able to look at BY and tell me what that is. What is it? It's 5, all right? Or I could make it just a little bit tougher. It's not much tougher, okay, but I could put a Z right here. And what if I told you that the radius of this circle was 5? What is the diameter of this circle? What would you say? You'd say it's 10, wouldn't you? All right, make sense? Okay, so the whole diameter right there would be 10. And you know what they're going to do probably. They're going to probably put X's in there, right, and all that kind of stuff. You might have to solve for X and blah, blah, blah. We've done that all year long, haven't we? But we're just doing the same thing that we've done all year. We're just doing it with different figures. That's really all we're doing. All right. Here's another one we're not really going to use too much, but it's kind of interesting. Let's make this a little bit bigger. Yeah, if you want to. And watch. Look what I'm trying to do. I'm trying to put that center of that one right where the center of the other one is. Look, they're two circles that share the same center. Everybody see that? The center is at the same exact point. Both centers are at the same exact point. We call those concentric circles. Concentric. So it's not just a circle inside a circle. I don't want to say that. Because look, if I would, let me click on this. Watch. I mean, that's a circle inside a circle, isn't it? Okay? But it's not a concentric circle. Why not? Because the centers are different places, okay? If they share the same center, then they're considered concentric circles. Everybody with me on that? Okay. It's easy enough. Again, we're not going to do a whole lot of stuff with that, but it's a good vocab word. There will be. Today, not so much. I mean, today basically just know that the diameter is twice the radius. Or the radius is what to the diameter? Half the diameter, right? Okay, know that. There's another thing we're going to need to know in a second, but let me do an example. Right, because what was the title of this lesson? Circles and Circumference. So what haven't we talked about yet? Yeah, but let's do this first. Actually, I just want to make this look a little bit more like the example. All right. Now there's two circles. Are they concentric circles? No. I don't know if there's a word for that or not. There might be. It's just intersecting circles, maybe? I don't know. I guess that's what I would call it, probably. And look what they do here. They connect the two centers, and they're going to label them. That one's, put a point right there. See where they intersect? That's C. Right where they intersect right here is D. And then this one is S right there. Okay? And look what they do. They tell you the diameter of circle S is 30. So let's just write it right here. The diameter, I'll just put D for diameter, okay, of circle S is equal to 30. 30 units, whatever. Inches, feet, miles, doesn't matter. Okay, it says the diameter of, I should just write it like that. The diameter of circle R is 20. It says line segment DS is 9. And the question says find the length of line segment CD. Put question mark. CD is question mark. Shouldn't be too hard, but it just kind of gives you an idea of what's going on here. So the diameter of circle S. Where's circle S? It's this one right here. The diameter is 30, correct? Do I really care about that part out there? Probably not so much. What does that tell me? If I say the diameter of circle S is 30, what does it tell me about line segments in here? CS is 15. Good. And let's do that in a different color. So CS, you okay if I do these little squiggly things? And what would that be? 15. Everybody see that? Okay. So that, if they tell you the diameter of S, remember this would be the radius of S, wouldn't it? From C to S is the radius of circle S. And that would be half of the diameter, which is 15. The diameter of circle R, so that's this little circle right here, is 20. So what does that tell you, do you think? RD is what? Is 10. They ask you for CD. Now, knowing that, that should make it pretty easy to find CD. CD is from here to here. Now look, the whole thing, is the whole thing 25? No, it's not. Right, that's right, because it's overlapped. You wouldn't just add them together, right, because you'd be adding an extra part. So it's not, but watch. This part is 10, this part is 15. CD is what's actually overlapping. How would you find out what's overlapping? Let me just make sure. Let's do this. And remember, DS is 9. Don't forget that. Because I was looking at this and I'm like, wait a minute, we got to know this. Watch. DS is 9. So from here to here is 9. All right, so that should be helpful. Right, you probably wouldn't know that without, you wouldn't be able to find CD without knowing this.
Please excuse the interruption. If you could please dismiss the girls' varsity softball team at this time. Thank you.
What? Where are you guys going? To our field? I mean, you're playing home? Why you get dismissed early? Hour early?
Our coach likes to stay 2 hours before.
What?
And that's Mr. Geisler.
2 hours before?
Yep. Hey, look, I'm using this pen.
People don't usually get dismissed for a home game early. Okay. All right. So what are we going to do? So DS is 9. Don't start working on the homework. So what are we going to do here? We want to find CD. So look, find the whole thing. What's RS? What's RS? Anybody here? What did she just do?
She keeps looking at the light. She like.
Oh, okay. Let's see, am I doing this right? CD plus DS plus 9. Say that again. Yes, you could, absolutely. I was thinking something. I don't know what I was thinking. I don't know. You know, I think I was just doing the math wrong in my head. I'm like, this is not working out right. So absolutely, watch. This whole thing, CS is 15, DS is 9, so what's left over? CD, right? So just 15 minus 9. And if I could have just done 15 minus 9 in my head, and for some reason I was thinking it was 4, and then I looked at the answer and it said it was 6. I'm like, wait a minute, what am I doing wrong? Well, arithmetic, right? It's not math. That's right. It's not real math. It's part math. It's not real math. Okay. That's correct. All right, enough of that. Let's do this. Let's talk about circumference. So we talked about radius, we talked about diameter. Let's talk about the circumference. What is the circumference of a circle? What are we finding if you find the circumference of a circle? The distance what? Around it, right? The distance around it. It's kind of like the perimeter, okay? Except they give it a special name for a circle and they call it the circumference. Circumference, write it down. Circumference is the distance around the circle. Probably knew that already. All right, but that's what the circumference is. It's the distance around the circle. So if I took a piece of string, let's say this, because it's kind of hard to measure unless your ruler bends like this one, but right, this bends kind of nice like that. All right, but a lot of rulers don't bend like that. But so how could I actually physically measure the distance around some circular object? Yeah, maybe use a piece of string or something, right? Wrap a string around it, okay, and then do what to it?
Measure it with a ruler.
Yeah, then pull it out straight, right, and measure the straight piece with a ruler, okay? If you have a, and that's what I'm going to do. All right, so, and I do have a piece of string. I tell you what, let's do this first, because I want to show you something. Circumference, we do have a formula for that, and there's two ways to write it. You could say it's 2 pi r. We'll talk about pi is what I'm going to talk about here in a second. Or, now watch, 2 times r is what? What's twice the radius? It's just the diameter. Or you could say pi d, which is pi times the diameter. Either one of those is the same exact thing, right? Does that make sense? Right? Twice the radius is the diameter, so it's really the same exact equation. But a lot of times 2 pi r is nice because they give you the radius, right? But how do you find the diameter? Just double it and then multiply by pi. Now, what do we know pi to be? 3.14, right? Does it stop right there? No, it doesn't. It's 159 blah blah blah. Okay, is that what it is? You know a bunch of them. That's all I know. And to tell you the truth, there's no practical reason to know any more. There's probably not even a practical reason to know that many right there. But it does keep on going, and it goes on forever. Notice the dot dot dot. It doesn't repeat any kind of a pattern. Every once in a while in there, it might have the same number next to each other, but then after that, it'll change numbers. It'll never ever change or repeat a pattern. And it'll never repeat the same numbers over and over again. We call that an irrational number. You ever hear that? It's an irrational number. It doesn't. Statistical reasoning, because if it doesn't do it after a few million places, it probably will never do it. So that's probably okay. You can argue all you want, but it doesn't. It doesn't. That's true. I mean, people taught stuff. People said the Earth was the center of the universe, and the Earth or the sun revolved around the Earth, and the Earth was flat, and all kinds of stuff. So science said a lot of things that weren't necessarily true. So you're absolutely right. You should question things. Okay, there's nothing wrong at all with you questioning things, and I have no problem with that at all. But don't question this because this is right. Okay, so watch what I'm going to do. Where does that pi, listen to me, where does pi come from? How in the world do we figure out what pi is? Well, let's use this. Right, so circumference is, we'll use the diameter. Pi times the diameter, okay? So what if I wanted to find what pi was? Let's do some math, some algebra, and solve for pi. What would pi equal in this formula right here?
C divided by D.
Good, c divided by d. All right? So that right there, why am I writing crooked? I don't know why. But pi is the circumference divided by the diameter. Does it say how big the circle has to be for that to be true? No, so that could be true for any size circle, okay? If we do it correctly, if you measure it correctly. Now, we're going to do this very crudely, okay? So I happen to have a circle right here. It's a clock, okay? And so, actually, let me get a piece of tape. Oh, somebody stole my tape. That's all right. My evils things are resting. This is not much. It's not very exciting on the video because they can't see anything.
Oh, it's actually really more exciting.
Isn't it exciting? Hit the light for me so I can see what I'm doing. Okay. All right, let's pay attention. This is not just free time to talk about stuff. Hey, let's pay attention. So watch. What I'm going to do is I'm going to wrap this around the clock. Rock around the clock. Used to be a song back in the day. Did you know that? Back in the day. That's correct. So I'm just going to put my finger here. Just believe me. Did you see that went around the circle? Okay. All right. Now what I want you to do, hold that like that, and we're going to start here. Measure all the figures. Does it go too long? Oh, it's pretty close. Now, I don't want to stretch it, but what do you think that is? It goes a little bit more than a meter. You think it's about a centimeter? It's about 1 centimeter. So 101. So we'll say it's 101. Okay, would you agree with that? Okay. All right. 101 centimeters. Okay. So now what did I just find? The 101. I wrapped it around. That's the circumference. Okay, 101. So now what I'm going to do, I don't even need a string for this, do I? Just use the ruler. So I'm going to take from here, does that go through the center? How much? About 32?
Yeah.
Okay. Now again, this might be off a little bit, but it should be pretty close. So 32. So 101 was my circumference, and my diameter was 32. So let's put that in there. Has anybody done that yet? I didn't say 31. I said 101. So 101 divided by, why am I doing this? Because I'm doing the circumference divided by the diameter to see how close I get for pi. And look at that. That's not bad at all. Look at that. To the hundredths place, okay, I was off just by 1/100th. That's pretty close, okay, as far as just using a piece of string. And we just kind of guessed a little bit that was a centimeter anyway, didn't we? Because it went just a little bit more than a meter. So that's right on. I mean, that's pretty close. Now, how do they do it with the computers and stuff? I really don't know. They have some crazy ways to do things. But that's how you can find what pi is. That's what pi is. Pi is just a little bit more than what? 3. Right. Pi is just a little bit more than 3. So what does that mean? That means if you have a diameter, listen now, if you have a diameter of a circle, the radius of that circle is just going to be a little bit more than what? Not just 3, but 3. No. A little more than 3 what? Times the diameter, right? The circumference, the distance around is going to be a little bit more than 3 times the distance all the way across. Let me give you homework.
Is there ever a circle that is not more than
No.
Ever?
Ever. It doesn't matter how big or small the circle is, that's always going to be true.
What is it
So you are doing 10 to 33 on page 687.
Which one? I can tell you all the stories that
It goes to 688 as well, but there you go. 10 to 33. 10 to 33.
My feeling